Okay, students, so now we're here with applications of similar triangles. So this is kind of just going to combine a lot of stuff we've been doing in the past, such as setting up ratios, proportions, cross-multiplying, but we're also going to be utilizing those theorems we were talking about yesterday. So we just had some theorems. That was kind of the prep work for what we're doing today. So what's powerful about this is indirect measurements, all right? Is a method of using proportions to find unknown lengths or distances in similar figures. All right, two common ways to achieve indirect measurement involve using a mirror on the ground and using shadow links to find an object's height. All right, and in a normal school year, we have actually done these as an activity, but not this time. Anywho, sometimes it is physically impossible or at least very challenging to directly measure a distance length. Some examples are a large body of water or a very tall object. Like, how do you measure the width of a lake? You know, you might be able to see across it, but you don't have a tape measure that can reach across. Or a tree, or even a tall hill. How do you measure? Like, how do they know how tall Mount Everest is? Well, you got to indirectly measure it. So let's just dive in some problems, just talk about things, practice our skills, so on and so forth. So what distance should the photographer place the camera from the 24-foot tall tree? So as we read this, let's fill in the information. If she wants the image of the height to be 56 millimeters. All right. So this image height is going to be 56 millimeters. All right. All right. The focal length, the image distance is 20 millimeters. All right, and we're not going to get too involved in units, but since we're going to have feet over feet and millimeters over millimeters, we won't have to worry about anything, no conversion needed. All right, so just realize we have this, the height of the trees, and how far it is away from the camera. Well, we're going to compare that to the image in the camera to the distance inside the camera. All right, so just very carefully, I'm going to do 24 over x equals 56 over 20. And again, setting this up, that's half the battle, because then here it's really just your math skills of cross multiplying, getting 56x. And what's 24 times 20? I think it's 480, and it is. All right, cool beans. Then divide both sides by 56. And x equals, wasn't expecting that, but we got 8.6, so a decimal. Neat. That's pretty cool. All right. Logan places a mirror on the floor of 220 centimeters from the base of the wall. All right, so looking right here, what's going on? We got a flashlight bouncing off a mirror. Remember, sometimes they use mirrors for indirect measurements. All right, from the base of the wall, it's 220 centimeters. He holds a flashlight 130 above the ground. All right, and he shines the beam into the mirror. How far must Logan stand back? So I think we're looking for this one right here, x. We're going to call that x. How far does Logan have to stand back from the mirror so the height of which the line shows is 100 centimeters greater than the height of which Logan holds his flashlight? So basically it's just saying we want 100 centimeters bigger. So what's 100 centimeters bigger? 230. All right. And then once we get here, again, just carefully organizing, we're going to compare 230 to 220 and 130 to x. All right. So 230 over 220, 130 over x. Cross multiply, I'm going to get 230x equals 28600. Then divide both sides by 230. So how far must Logan stand back? Well, let's compute that number, and it comes out to be 124 centimeters, 0.3. 124.3 centimeters. Getting a lot of fractions today, pretty crazy. All right, nothing wrong with fractions though, I like fractions. All right, nonetheless, let's continue on. Kendall is 5.5 feet tall. She measured the shadow of a tree and found it was 5.5 feet long. She immediately measured her own shadow, which was 1.375 feet. How tall is the tree? So basically, you got some human named Kendall, and Kendall is 5.5 feet tall. And again, let me make this a little bit more accurate. And then there's Kendall's shadow, 1.375. And then there's a tree. If you guys didn't know this, I'm a very good drawer. If you haven't noticed, I'm probably one of the best drawing teachers at Darby High School. The tree shadow is 5.5. How tall is the tree? All right, we need to figure out the height of the tree. So what do I got to do here? Again, let's just focus on what I know. Kendall's 5.5 feet tall. Their shadow is 1.375 feet. The height of the tree we don't know, but the shadow of the tree was 5.5. So again, keeping your work organized, and then from here, boom, boom, just a matter of cross multiplying. What's 5.5 times 5.5? 30.25. Divide both sides by 1.375. Divide both sides by 1.375. And we're going to get the tree has a height of 18.1-ish. All right, so in these first few examples, we saw an example of how we can use this for photography and how they use this kind of similar triangles to create cameras, how you can use it for a mirror to find indirect heights, shadows. So we're kind of seeing a good array of stuff right now. All right, a tree outside of Ellie's building cast a 125-foot shadow. All right, we'll make this one a palm tree. I always thought it'd be cool if there was palm trees in Ohio, but because science, there's not. All right, cast a 125-foot shadow. At the same time, Ellie cast a 5.5-foot shadow. All right, we're gonna make Ellie look a little weird. We're gonna give Ellie big ears and crazy hair, almost like Ellie just got zapped by lightning, and a weird mouth. That's Ellie. Ellie's shadow is Ellie's having a bad hair day. All right, and Ellie is short. Ellie's only 5'10". All right, so really fast, to convert this as a decimal, we need to do 10 divided by 12. This is something good to think about. 5 divided by 12 is about 0.83. So we're going to say Ellie is 4.83 feet tall instead of 4 feet 10 inches. Because we can run into some issues, just how like the shadow was 5.5 feet, so on and so forth. Approximately how tall is the tree? So again, we're just finding another tree height. Apparently whoever made up these problems that I stole them from loved to find heights of trees. So again, just compare Ellie's height to her shadow. We need to find the tree height compared, and we can compare that to its shadow. So 4.83, 5.5 equals t over 125. Then again, all I gotta do is cross multiply. I'm gonna get about 5.5t equals 104.16. That's repeating 1.1666666, so on and so forth. Divide both sides by 5.5. And t will equal 18.9-ish. All right, so a lot of decimals, but and when you do measurements in the real world, finding heights of things, lengths of things, just real world calculations typically involve decimals. Very rarely do you just get nice clean numbers the whole time. All right, stay tuned for more.